Hello children, how are you all? Hope you have enjoyed the previous video lesson that I have sent to you. And what was the thing that we have learned in the previous lesson, children? So we learned that there are some pure substances which are called as elements and compounds. Now what are elements? Elements are those basic substances which are necessary for forming what is called as all the substances of nature. So these are the basics, and they cannot be converted into simpler substances by any chemical reactions. Okay, like these elements again were divided into three groups. What is that, children? What was that? Now next one, right, the metals, the non-metals, and the metalloids. The 92 of them metals, the next 20 of them non-metals, and we have the other one, what is called as the metalloids. Now all of these, they combine and add up to be 118 elements. Okay, good. Right, we have also seen the difference between the metals, the non-metals, and the metalloids. Okay, right, and some of the utility of these metals, non-metals, and the metalloids. Okay, that's good of you. Right, hope you have enjoyed that part. Now let us deal with what we call as compounds. Now we learned well in the previous part. I've also explained to you that metals or elements, elements on the whole, metals, non-metals, or whatever, they combine and they produce what are called as compounds. Right? So this is what we have learned. Now we'll get into the details of what are called as compounds. What is that, children? Compounds. Now, okay, right. So what are compounds? So as you know, they are also pure substances. But how do they form? From metals initially. Okay, these compounds again, they can combine in various ways and produce some more compounds. So all the substances that are there in the universe, otherwise anywhere, they are chiefly made from elements, and from these elements you find the compounds formed, and again so many compounds are formed. So there are 118 elements, but the number of compounds is innumerable. There are so many. Okay, just like your alphabet. Okay, right, in the previous video we have learned. Now let us talk about compounds. So for this, in order to understand what a compound is, what type of combination that elements have undergone in order to produce compounds, I'll do a small activity. Now let us perform this, children. So we'll be doing that. Okay, children, say I have powdered iron, iron filings, and sulfur powder. I take 5 grams of iron filings and 3 grams of sulfur. Right? Okay. So I take 2 groups of it. That is, in the first group, I take 5 grams of iron and 3 grams of sulfur. In a watch glass here, in the first group, we mix them up very well, and I get one mixture. And the next one, and I take the same constituents, 5 grams of iron, and the next 3 grams of sulfur powder. Mix that well. Now we don't find any difference here, but I am now heating the group 2 substance, that is that mixture, over a Bunsen burner and see what happens. I'll wait, heat it, wait it, and then I get some substance there. Okay, that's a mixture, that's also a mixture. Right? Now let us test this mixture of group 1 and that group 2 by using some testers, I should say. So the first tester is a magnet. Now I take a magnet, right? Before this, I'll divide this mixture into certain parts, say 3 parts of it, right? 3 parts of it. So I have this 8 gram of mixture here that I have divided into 3 parts, 1, 2, 3. So 3 parts. And here also I divide this mixture into 3 parts. Okay, I have kept them. Now I want to test them. In the first part of this mixture, I take a magnet and the next thrust that magnet into that first part of that mixture and move it in that and take out and see. And what do I find? I find so many iron filings that are there, that were there in that mixture, coming and clinging to this magnet. Okay, right. So in one way I have separated this very simply, very, very easily. I have separated iron from that mixture. Okay. My next one, the second one. I take now, as I told you, I divided that mixture also into 3 parts. In the first part, I take a magnet, thrust into it, I move it, and check. And I find that there were no iron filings clinging to this magnet. Okay. Do we know that there is iron there? Yes, we know that. There is iron here and there is iron there. But now, when I moved the magnet, I did not get any iron here. So I am not able to separate by a physical technique. So this substance, from this substance, I am not able to separate what is called iron, which is there in it, but I am not able to separate it by simple magnetic separation technique. Okay. Now, what I do now is I take a carbon disulfide. It is a solvent, and that carbon disulfide I take and in a beaker and put the second part of the first group's mixture and put it in that and try to dissolve. I find that a solution is formed, and when I filter it, I can get only iron. The color of iron is visible, and I don't see any sulfur, that yellow colored sulfur substance visible to that visible in that mixture. So what is this, children? So now this way I have used carbon disulfide and separated sulfur and iron. So what is this technique? It's a very simple process of separation of substances. Okay. Now, and into that I go. I take carbon disulfide again in another beaker. I put that second part of that mixture and dissolve it. And I find that even in spite of trying to dissolve, it doesn't get dissolved in it. So I know that there is sulfur in it, but I'm not able to separate sulfur and iron by a simple technique of using a solvent and trying to dissolve it. So I failed there. Now I am left with the last parts of these two mixtures. Now what I do is I take the last part of this mixture, the first group's mixture, and put it in a test tube containing sulfuric acid, and I immediately I find an effervescence and some gas coming out. And if I test that gas with a burning splinter, there it gives a pop sound indicating that the gas produced, we know well, is hydrogen gas. Okay, right. So this mixture, when put in sulfuric acid, has produced hydrogen gas. We know well that metals, on reacting with acids, they produce hydrogen gas. So we understand there is a metal called iron in that, and that reacted with the sulfuric acid and produced what is called as hydrogen gas. Very good. Now we are going to the next, and we are going to test whether that part, the third part of that group's mixture, also gives hydrogen. So we'll check. So what is that? And I take sulfuric acid in that test tube, in a test tube again, and the next to put the third part of that mixture into this test tube, and I find a a pungent, odored gas is coming out, and that smells like rotten eggs. So this gas is not hydrogen. Why? Why? Because the hydrogen gas that was produced here, it was colorless, odorless. It was not having any smell here. But here, how is that? It is having an odor. So children, I find that this gas is not hydrogen. So when I check these two mixtures, I find there are so many differences between these two. So what are those differences? We'll analyze and understand something very important. Okay? So children, right, we are now seeing the differences between these two mixtures. In the first one, so how is this mixture? This mixture, in the first thing, what happened was we were able to separate iron from sulfur. One. Second, we were able to separate sulfur from iron. Okay, good. And the third one, we found that hydrogen gas was coming out because we know well one of the constituents, that is iron and sulfur, from these two we have iron, which is a metal, and that metal reacted with sulfuric acid and it produced hydrogen gas. So that is the characteristic of a metal. They produce hydrogen gas, as we have learned before. Okay children, right? So here in this mixture, we find the constituents are showing their individual properties. So what do I understand? I am also able to separate the constituents easily by physical techniques. Okay, dissolution, or otherwise, what is that? Magnet. Okay, right, that's it. These are the ways in which I have separated them. That's good. Now when I went into there and performed the same activities there, I found that it was impossible for me to separate those constituents, that is sulfur and iron, from that using physical techniques. And the product, the type of chemical reaction here and the type of chemical reaction there, they were not same. So that substance is different from this. Now this is not a substance. There are two substances, that is sulfur and iron, and these two, they have just formed what is called a mixture. What is that, children? Mixture. They formed a mixture, a physical mixture. They are not combined chemically to form what is called a compound. When I call sulfur, are you there? It will say, I am here. When I call iron, are you here? Then it says, yes, I am here. They are showing the individual characters of the metals, though they are in a mixture. So they have not formed a compound, right? So they are just a physical mixture. So a physical mixture is not a compound. Now let us go into that. When I call, yes, hello, iron, I am magnet, come on, come out. Will it come out? It has not come out. So I understand iron is there, but it has changed its nature, right there. So what is the reason? Right, that reason is plainly this. It has entered into what is called as a chemical combination or a chemical reaction and formed a compound with sulfur. Okay, so iron that was previously able to get attracted to the magnet now has combined with sulfur and has lost all its properties. So the individual elements in a compound, they don't show their properties. Right, we were not able to separate them physically also. Right, next one. What is the next? We use carbon disulfide. So if I say, hi iron, hi sulfur, I'm carbon disulfide, come out, we'll go out. Then it says nothing. Do you know why? Because it is not having the same characteristics. It doesn't recognize carbon disulfide now because it's not a friend of carbon disulfide anymore. Right? That way, what happens is that sulfur doesn't get separated from that mixture. So this mixture is not a physical mixture. Iron and sulfur in this iron and sulfur in this case have combined. Now, what kind of combination is this? This combination is not just a physical combination. but it is a chemical combination. Now, if I test these two for texture, check the color and texture. I find here and there the brown colored iron or the black colored iron, you can say iron powder, and yellow colored sulfur powder here and there. So I can easily recognize the difference. But when I go there and see that substance, I don't find these two separate. So that I don't find yellow colored sulfur and that black colored iron, but a different mass is formed there. And the texture is uniform. Uniform means wherever you find, the texture is same. There's no difference. Now, this and this is there any difference? This is just a physical mixture. That is a chemical combination of two elements, and that is a compound. So now, do you understand the difference, children? Now, what a mixture is and what a compound is. So, a physical mixture is a mixture, and there a chemical combination is producing what is called a compound. So, children, just list out the differences between the compound, the mixture and the compound now. So, children, now we will list out the differences between the mixture and the compound. In a mixture, the substances or the pure substances or the elements, they're just mixed up physically. And in a compound, we find that there is a chemical combination, or you can say between the particles of these elements, there's a kind of a strong bond formed, which is called as chemical bond. So that is it. And here, you don't find any new substance formed, but in that case, there are new substances formed. A single new substance is formed by chemical combination. And here, the individual substances, they show their characteristics. And there, both the elements involved there, they have lost their characteristics. Okay, that's a new substance. And can we separate these elements out of this mixture physically? Yes, it is. And about that, so we will not be able to separate the components physically. And when we check the composition here, composition, it's all variable composition. I mean, just take out a part of it from that, say 2 grams of it, and try to separate. Say if you got 1 gram of sulfur and say 1 gram of iron, but in that case, if you try to separate them by what are called as chemical reactions, so there are processes called as thermochemical reactions or chemical reactions, or otherwise electrochemical process, you can separate them. That's a tedious process. This group is a very easy process, physical process. But when you separate them, you take any amount from anywhere, you find that the proportion is constant. So in a compound, the elements combine in a definite proportion, whereas in a mixture, the proportion is not uniform. Okay, children, hope you have followed this. Now, let us recapitulate on what we have learned today. First one, elements, they combine to form compounds. Okay, good. Then how do they combine is the question. What's the question I should say? And what was the combination, children? It's not just a physical combination, but there's a chemical combination. And we have also seen the differences between the what is that physical combination, which is called a mixture, and also the compound. So, right, children, we have seen the differences. Now, okay, right, okay, can you name some compounds generally around you? Okay, right. So, there's one compound we need to use every day to quench our thirst. Can you tell what it is? It is water, yes. Now, this water is made up of hydrogen and oxygen, and when they combine, the other day we have seen they burn down or burn up and form what is called as water, right? Okay, that's it. The next one, anything else? Yes, we have carbon dioxide, a very important gas required for plants to prepare all the food, right? Okay, next. Anything else? Anything else, children? So there are many more such compounds which are very, very essential. Our food is a compound. and it's a combination of so many substances. Okay, carbon dioxide and water in the presence of sunlight, they combine. Okay, not only elements combine to form compounds, but also compounds also can combine to form compounds. That's an example. And our common salt. Okay, the seasoning salt. What is that made up of? Two elements, sodium, chlorine. So it's called sodium chloride. Okay, children. So this is how we conclude this part about compounds. Thank you very much.